Up until this point, we've been focusing on linear functions. Linear functions are ones when we graph them, either using an input-output table or intercepts or slope-intercept form, we get a straight line. It's a linear function. If you look at this example here, this is called an exponential function. And the reason it's an exponential function is because our variable, our x, or our input, is an exponent. So this is the form of an exponential function. Y equals a number times another number raised to your input value. Okay, now it does say b has to be greater than 0, so our base has to be a number bigger than 0, and our base cannot be 1. The reason for it is 1 raised to any number is going to be 1, so this ends up being just you're multiplying by 1. Now, if we want to graph a function, there really is no other way to do it but to create an input-output table. So for our example here, it says sketch the graph of y equals 4 raised to the x. Make an input-output table. We're going to input numbers. Again, they can be whatever you want. But if you pick a negative 102, you have to graph a negative 102, so keep that in mind. And that gives us our output values. Safe ones to stick with are numbers like this, negative 2, negative 1, 1, and 2. And what you're going to do is you're going to plug these input values in for x. We're going to get an ordered pair and be able to graph it. So in this case, I'm going to say 4 raised to the negative 2. Now remember, all those exponent rules we just practiced, there was a reason for it. If we raise it to the negative 2, remember that's like saying the reciprocal, 1 over 4 to the second, or 1 over 16. Let me put that over here. Our y value is 1 over 16. Okay? So it's going to be an ordered pair, negative 2, 1/16. Now, I know we're going to want to type these into our calculators, and it'll be okay because we're just going to have to pretty much approximate on the graph. Just understand that that's a pretty small number. It's pretty close to 0. If I put a negative 1 in, I get 4 to the negative 1, which is like saying 1 over 4 to the first, or just 1/4. Negative 1, 1/4. So still pretty small, but bigger than 1/16. If we put a 0 in, 4 to the 0, remember, anything raised to the 0 power is 1. If I put a 1 in, 4 to the first power is 4. Oops, I'm sorry. So we get a 1 here and we get a 4. These are going to be ordered paired 0, 1. And this will be the ordered pair 1, 4. And then if we put a 2 in, we get 4 to the second. 4 times 4 is 16. So we get the point 2, 16. So what we want to do now is we want to take all of our ordered pairs and put them on a graph. I'm going to move them over here. Now, negative 2, 1/16. If I just kind of go by ones here, it won't be big enough for the 16th, but we'll talk about that. Negative 2 is right here. This is 1. So 1/16 is going to be really, really close to the 0, really close to our x-axis. It's not the x-axis though, and in fact, it's never going to, the smaller numbers you go, you're never going to get a negative number. If I put a, well, let me talk about that for a second. Let's say I wanted to put a number in like negative 10. If I plug a negative 10 in here, I'm going to get 4 to the negative 10th, which is like saying 1 over 4 to the 10th. Now, whatever 4 to the 10th is, 1 over that's going to be a very, very small number. But notice it's still going to be positive. That's what I mean, that when you see our graph here, it's never going to cross this x-axis. Okay, so negative 1, 1/4, it's about a quarter of the way up. Not a big difference. 0, 1, 1, 4, and then 2, 16. So that's going to be way up here. Now, you notice what your graph looks like. If you draw a line through it, which I'm not very good at, try again, you're going to see that it's going pretty steady, and then all of a sudden it takes off. And it goes higher and higher pretty quickly. What we say steeply. Now on this side, remember we just talked about, it's never going to touch your it's never going to hit the x-axis, even though it looks like it's touching it. Okay, so you kind of just draw it along. And I apologize, it's hard for me to do that with this pen. But this is what an exponential function looks like. It's very, very slowly growing, then boom, all of a sudden it takes off and it increases pretty rapidly. So to graph an exponential function, you have to make an input-output table. Try using about 5 points so you can actually see where it's curving at. These are pretty safe ones to test, -2, -1, 0, 1, and 2. When you're doing that, keep in mind of your zero property, anything raised to 0 is 1, and your negative exponent property. A negative exponent is like taking the reciprocal. And you're going to get pretty small numbers, but on a graph, those will never cross your x-axis.